Have you ever wondered how Python sets up an object the moment you create it? Like, when you write player equals player with the name Zara and 100 health points, how does Python know to give that player the name Zara and 100 health automatically? The answer is the underscore init parentheses method. And by the end of this tutorial, you will understand it so deeply, you will never be confused by it again. We are going from absolute basics all the way to advanced patterns used in real-world Python projects. Let us get into it. Before we touch init, let us make sure the foundation is solid. A class is like a template or a blueprint. Think of it like a cookie cutter. The cutter itself is not a cookie, but every cookie you make with it follows the same shape. When you create an instance of a class, you're making a real object from that blueprint. But here's the problem. Both players are identical blank slates. They have no name, no health, no level. That is where init comes in. Init is a special method that Python calls automatically every single time you create a new object. It lets you set up your object with initial data right from the start. Let us build a simple player class and add init. Watch as we define the init method with two parameters, name and health. Now when we create player1 by calling player with Zara and 100, something magical happens. Python first creates a new empty object, then automatically calls init and passes that new object as self. The line self name equals name attaches Zara to this specific object, and self time health equals health attaches 100 to this specific object. Finally, the configured object is assigned to player1. The magic is that each instance keeps its own data. Player1 has Zara and 100 health, while player2 has Kai and 80 health. They are completely separate. Self confuses nearly every Python beginner. Let us fix that right now. When you write player1 equals player with Zara and 100, Python is actually doing this behind the scenes. It calls player.init with player1, Zara, and 100. Python automatically passes the object itself as the first argument. You do not call it. Python does. That is what self is. A reference to the specific instance being created. Self is the object. You are stamping data onto it. Important note, self is just a naming convention. You could name it anything like this or me, but the entire Python community uses self. Always stick with self. Init can take as many parameters as your object needs. Let us look at a real-world example, a bank account class. Our init method takes owner, account number, and an optional balance with a default of 0. Watch how we create an account for Alice with account number ACC-001 and a starting balance of $500. Each parameter becomes an attribute of the instance. We can also add methods like deposit and withdraw that operate on these attributes. When Alice deposits $200, the balance increases to $700. When she withdraws $100, it goes down to $600. This is how you create rich data-filled objects in Python. Sometimes you want parameters to be optional. You do that by assigning a default value in init. Look at this notification class. It takes a required message parameter, but priority defaults to normal and is read defaults to false. When we create n1 with just a message, it automatically gets priority normal and is read false. But for n2, we override just the priority to urgent while keeping is read as false. Important rule. Parameters with defaults must always come after parameters without defaults. If you put a default parameter before a required one, Python will throw a syntax error. Always put required parameters first, then optional ones with defaults. One of the most powerful uses of init is validating data before your object is created. This prevents broken objects from ever existing. Look at this rectangle class. In init, we check if width or height are less than or equal to 0. If they are, we raise a value error with a clear message explaining what went wrong. Only if the validation passes do we assign the attributes and compute the area. This is called fail fast and fail loud. When we try to create a rectangle with negative width, Python immediately raises an error instead of letting us create a broken object. Always validate your inputs in init to ensure your objects are always in a valid state. You can compute and store additional attributes inside init based on the input values. This is perfect for derived values that would be expensive to recalculate every time. Look at this circle class. We take a single radius parameter, but then we compute and store the diameter, area, and circumference right in init. The diameter is simply radius times 2. The area is pi times radius squared. The circumference is 2 times pi times radius. Now, whenever we need these values, they are already calculated and ready to use. This is much more efficient than computing them every time we access them. Just make sure the computation is not too heavy or consider lazy loading instead. This is one of the most common and dangerous bugs Python beginners write. Never use a mutable default like an empty list in your init parameters. Here is why. When you define a class with songs equals an empty list as a default, that list is created once when the class is defined, not each time you create an instance. So when we create P1 and P2, they both share the exact same list object in memory. When we append a song to P1, it also appears in P2. That is almost never what you want. The correct way is to use none as the default. Then check if songs is none inside init and create a new empty list only if it is. This rule applies to any mutable default, lists, dictionaries, or sets. Always default to none and create the mutable object inside init. This distinction trips up many developers. Let us make it crystal clear. An instance variable using self.x is unique to each object. A class variable defined outside init is shared across all instances. Look at this employee class. Company and employee count are class variables. They are shared by all employees. When we create E1, E2, and E3, each one increments the shared employee count and gets a unique employee ID, but they all share the same company name. When we change employee.company to NewTek Corp, all instances see the change. Use instance variables for data unique to each object and class variables for data shared across all instances. When a class inherits from another, you need to call the parent's init to make sure the parent sets itself up too. You do this with super. Look at this vehicle class with its init that sets up make, model, year, and is running. Now electric car inherits from vehicle. In its init, it calls super.init with make, model, and year. This sets up all the parent attributes. Then it adds its own specific attributes like battery capacity and charge level. Gas car does the same thing, calling super to set up the shared attributes, then adding tank size and fuel level. Always call super.init in a subclass if the parent has one. Forgetting it means the parent's setup code never runs, leaving your object in a broken state. When you want maximum flexibility, for example, building a framework or a utility class, you can use args and catch rides. Args captures any extra positional arguments as a tuple. Catch rides captures any extra keyword arguments as a dictionary. Look at this data record class. It takes a required record ID, then any number of tags as positional arguments, and any number of metadata fields as keyword arguments. When we create a record with ID 42, 3 tags, and 2 metadata fields, all of them are captured and stored. This pattern is extremely useful when you cannot predict what parameters callers might want to pass. Init works best when paired with other special methods. Dunder methods, named with double underscores. Let your objects behave like built-in types. Look at this vector2d class. Init sets up the x and y coordinates. Stro makes print readable for humans. Rep makes it readable for developers in the debugger. Add lets you use the plus operator to add vectors. Mul lets you multiply by a scalar. EQ lets you compare vectors for equality. Now when you print v1, you get a nice human-readable string. When you add v1 plus v2, Python calls the add method automatically. When you multiply v1 times 2, it calls mul. This is how you create truly Pythonic objects. In large projects, you will define abstract base classes that force subclasses to implement certain behavior while sharing initialization logic. Look at this shape abstract base class. Its init sets up shared attributes like color and filled, but area and perimeter are marked as abstract methods. This means any subclass must implement them, or Python will not let you create an instance. Square and triangle both call super.init to set up the shared attributes, then implement their own area and perimeter calculations. The describe method in the base class works for all shapes because they all implement the required methods. This is how you enforce interface contracts in Python. Sometimes you want multiple ways to create an object. Instead of making init messy, use class methods as alternative constructors. Look at this color class. The primary init takes red, green, and blue values, but we also have from hex, which creates a color from a hex string, like hash FF5733, and from CSS name, which creates a color from a named CSS color like blue or red. These class methods all call init internally, but they provide cleaner APIs for different use cases. When you call from hex, it parses the hex string, extracts the RGB values, and returns KLS with those values, which calls init. This is the factory pattern in Python. Here are some pro tips for writing production-ready init methods. Do use type hints to make your code self-documenting. Do write doc strings that explain each parameter. Do validate early and fail loudly before assigning attributes. Do prefix private attributes with an underscore to signal they are for internal use only. Do not use mutable defaults. Always use none instead. Do not put heavy logic in init. Use lazy loading when appropriate. Do not make init do too much. Keep it focused on initialization. Following these best practices will make your code cleaner, more maintainable, and less bug-prone. And that is init, from the ground up to production-ready patterns. Here's what we covered: how init works and why it exists. The self parameter explained clearly, validation, defaults and computed attributes, the mutable default argument trap, class versus instance variables, inheritance with super.init, *args, and double *cat grids for flexibility, Dunder methods, abstract classes, and the factory pattern. If this helped you, like and subscribe. More Python tutorials like this are on the way. Drop a comment with what you would like to see next. Happy coding!